Sravani is there. Aditya. Josina is not there. Mahuri is there. Satya. Okay, I'm trying to remember. Satya, Shian. Nivan. Rojian. That's Justin. Wanjang. Wait a second. Wanjang, you? Sure? Yeah. And you are? Yuan Zhang. Okay. Jia is not there. Jia is there.
Jia's here.
Okay. Shinze. Here. Yuming. And Jing is here. Okay, so we have Lauren and Kim Song. All right. That's why. Sorry. Very good. So let me tell you what we're doing on today's lecture. We're going to quickly go through these, various design patterns. We're not going to go in depth to them. We're just going to zoom through. But then we're going to spend a lot of time with the repository pattern, with the code. We're going to spend some time on the block pattern with qubit and block and understand how they are used. And then I'm going to explain to you what to do for your homework, which is due in 1 week's time. Okay? I've already uploaded it to the assignments for homework 3 with instructions, and there's a Figma file telling you what to do and what type of behavior to do. But most importantly, you need to do the transition using the block pattern to exercise that and to understand that. And also, it'll give you the experience again to code the UI, which is important. And by the way, have you guys started thinking at all about what app you're going to do? Because we're in week 4. I think it would be nice if you could get together with your group and start coming up with a sketch of what it is, because at not too far from now will require the 1-pager of the app, right? With a good idea of what it's going to look like, what functionality it will have, what's the logic, etc. Okay, so let's shoot off with the design patterns. So what do I mean when we say design pattern? Can somebody explain what do I mean by design pattern? Yeah.
Like the structure of the coding, like how you usually follow the structure of how to organize the widgets and how they talk to each other, I guess. Okay,
so Josine said the structure of the code. Basically, you can look up on internet, something called the clean architecture, which says that, your business logic of what you want to do should sit in the core. And then layer by layer goes things that are sort of replaceable. For example, if you're holding your data in a database, your business logic should not know anything about, how you connect to the database, what credentials you give to the database, and what is the specific way of calling that database. Because tomorrow, you may say that database doesn't work anymore, it doesn't meet my requirements, you want to change the database. You don't want to change the core of your code. Okay, so the idea is that these design patterns give us some way of method of organizing our code so that we have a better development experience, and we have a better development experience for the code, and also better usability, better maintainability, and everything that comes with it. It may be a little bit lengthier to start in the beginning to apply these design patterns, because you need to think about it. You can't just go in and start coding and connect to a database, connect to this, connect to that. You need to think about things. But if you do, the benefits in the future are a lot. So some of the design patterns, and these are used in parts of the code. They are not exclusive with each other. Is the business logic component, which is a favorite for the Flutter development, especially. The provider is an earlier way of doing things. The model view model versus model view controller model. We're just gonna see that. The repository pattern, we're gonna go really in depth to this. Then there are certain state management patterns, like inherited widgets, scope model, etc. Factory models, singleton models to allow for, we're going to talk to that in a minute, that allow for a single instance of a class, adapter, builder, and observer, which we're going to talk really quickly now. So in the business logic component pattern, we have the UI layer, which triggers events, right? When the user sees an UI layer, he clicks on a button, he types in some text, etc. That's an event, okay? Then the event is captured by the BloC, right? Captured by the BloC. And the BloC says, okay, this event occurred, what am I supposed to do? Now, as a coder, as a business owner, you have put in the business logic in there. If this happens, do that, okay? Then the business logic component, or it may also go and get some data. It may write some data into a database. But ultimately, after the user has interacted with us, we are now in a new state, right? We are in a new state. We can be in a state that, okay, I want to show you your profile page, or he clicked on something else. Okay, now I'm going to show you your shopping cart, etc. So I'm in a new state. So the BloC then emits the new state, okay? And the BloC's job is done at that point. Now it's the job of the UI to repaint itself or show the necessary screens based on that emitted state. One of the things that happen, for example, you can have in your code multiple points which triggers seeing the shopping cart, right? You can have multiple buttons which sees the shopping cart. Now, you can assign a different event to each of these clicks. Seeing the shopping cart while you're browsing a list of items is one event, or looking to see your shopping cart when you are on a single detail view of an object is another event. The thing is, all of these events, when they come into the BloC, you can say, oh, all of these things change the state to a shopping cart, right? But I can then, if there is something going wrong, by tracing the event, I can say, okay, this event has a problem associated with it, but this event doesn't. So it increases the testability of your code by doing the events. You could, of course, think about it. You could, of course, call a method somewhere that shows you that page. But who called that method? You don't know, right? Other places, and then you cannot test it very well. anyway, so that's the block pattern. We're going to talk in depth about this. The next thing is a provider pattern. I mean, I don't personally use the provider because the block pattern already gives you a superset of everything that the provider does. It's typically for smaller codes, tighter codes, and basically you take a widget, say the root widget of your app, you wrap it with a provider, and let's say the provider is some kind of a data source. And then any widget underneath can access the provider and access the stuff inside the provider. So that gives a way of organizing your code, so you don't have to care about where that data is by just wrapping your widgets with a provider. Now, the next pattern is the model view model pattern. You have a model that for example, our user model, right? Our user model represents the user from our perspective, what we need to see about the user, first name, last name, image, etc. And so our user pattern does encapsulate all the data that we need about the user. Then there are certain methods to go and fetch that user from the database. Then you have a view that displays that model, whatever that model is. And then you have a view model which basically says, I have this data here, and I have this presentation layer. How am I going to put this data into the presentation layer? That's the view model. And this way, the view and model are separated, right? You have the view model. So the view model is the one that you need to worry about if you want to make changes. You don't need to worry about the view itself. It's really separated. And this is sort of the high-level difference between the model view controller to model view model. When you had the model view controller, you still had the potential from the view to go to the model with a request response to update the view. And you're now breaking this link completely, and you're delegating everything to the view model such that you have a better organized code. Yeah.
Is this particular design pattern more for like scalability point of view, or it is more from like a security point of view?
For what kind of view?
Is it more for like a security point of view, privacy point of view, or more like a scalability point?
Scalability, nothing to do with security.
Okay.
None of this have anything to do with security. Now, the repository pattern, again, the basic idea is that today, let's say you're, again, using a database, Oracle database, and you want to switch to Microsoft database, Microsoft SQL database. And if what is the best way to abstract this, right? That's what the repository pattern does. It basically, in your code, you want you have certain predefined SQL queries that you're sending, and it's bringing data. That's what you define. Now, but there is a lot more, let's say, there's a lot more stuff going on connecting to a Microsoft database or an Oracle database. It could have different credentials, it has different API endpoints. One of them could be connecting with a GET HTTP GET, the other one could be with an HTTP POST, whatever, could have various different peculiarities with them. So you don't want to build any of that in your code. You build them into the repositories, and you create, in this case, a repository abstract class with certain methods that you use in your code. And anytime you want to replace that repository, you create another class with the same abstract method or with the implementation of that abstract method, so that your code is completely oblivious that you've gone from Oracle to Microsoft, okay? And we're going to see a very detailed example of that with the code. Again, state management patterns, the StateNotifier, again, is for lightweight code. It's, again, encapsulated all in Flutter BloC. So it's not really something that we need to pay attention to. Inherited widget is also something that can share its data down the tree. And scope model is a similar pattern. Again, these are not things that we're going to have to deal with. Factory patterns, you may know it from your other classes, that there is a factory constructor for the objects. Again, it increases the usability of the code. The singleton pattern is a pattern for creating an object only when necessary and not creating multiple copies of that object. So the singleton pattern doesn't have a explicit constructor, so you cannot construct it explicitly. You only have a getter method. It gives you a instance of the model, and it only creates that instance at the last minute. The builder pattern is a little bit less relevant. It's you can think of, when we're building the user class, for example, imagine we need to fill everything in at the one go, right? You have to fill into the user class the first name, last name, email, image, and what was it? UID. We have to fill all 5 elements in one go. But if I had a user builder class, which I can incrementally build, and then it will have a state that this is built, and then I can create a user object out of it, it gives me some flexibility. So the builder pattern, a good example of the builder pattern is it takes you away from having to build an object in one go to incrementally building it as you have the data available. Sort of like cooking it step by step versus cooking it in one go. Adapter pattern, again, it's just adapters that you build in your code to translate from one version of the API to another. It's not a hugely interesting pattern. And the last one is the observer pattern. The observer pattern is one where you have think of like you have an FX trading app. Okay, in an FX trading app, you have the FX pairs, dollar euro, dollar Canadian, dollar Aussie, dollar Kiwi, dollar sterling, etc. And in various places in your app, these pairs will be displayed. These currency pairs will be displayed. This number will be displayed. So now, for you centrally to go and say change these numbers is going to be a complete mess. It's much easier if you had these UI objects, when they are created, they go and try to subscribe to a source, right? And that would be the way that whenever that is painted on the screen, it comes with it's an observer that observe that source data and it can, once again, it can be done with the block pattern with the block builder. And this is a sort of a breakdown of when to use it and why is it useful. And yeah, so we're going to now go in depth into the provider pattern. Any questions so far? Okay. Oh, sorry, did I say provider? Repository pattern. Okay, so let's say, and this is, we have this, by the way, in the code. So today's code is going to start with this already coded in. We're going to look into the code, but here I have the excerpt of the code so we can look in depth. So I create an abstract class called authentication repository, which has a method sign in. Okay? Because it's an abstract class, the method doesn't do anything. I mean, the method is just empty. It's just a placeholder, a name, that if I extend this class, right, the new class has to have that method, right? What is abstract class? Again, is you define a method. You basically say that if you extend this, you'll have to definitely implement this sign-in method. And you implement the sign-in method with an override in Flutter. Maybe you've seen it. And we can have two authentication repositories. Let's say one of them is with Firebase, the other one is with Okta. Okay? Now we're going to inject this authentication repository to any widget that requires an instance of it. Okay, or I'll wrap my top level, my root level widget with this authentication repository. The thing is, any widget that I write, so this is the same widget, any widget that I write, it only requires that it has a repository that has a sign-in method that I can call in a particular way, right? It doesn't matter if it's a repository coming from, if in the backend there is Firebase working, if in the backend Okta is working, okay? So to get a better idea, I create an abstract class authentication repository. I put a sign-in method that returns a future user. Why? Because nobody will sign me in instantaneously, right? They will sign me in always with a delay, so asynchronously. So it returns a future user, and as you can see, this method has arguments, but it has no implementation. Now, we create two new methods, Firebase and Okta, and in both of them, I need to implement the abstract class method, the class I'm extending, which is authentication repository. I need to implement the sign-in method of it, specific to Firebase or Okta. Okay? And here, what I have done is the following, because I don't want to deal with all the coding, but let's say this one, before sending me a mock user, he's basically sending me a user. It will send me a proper user in the proper implementation, but here I'm just sending an arbitrary user object with my create mock user. But before that, it goes and calls some Okta-specific code inside it, okay? whatever it needs to do. Maybe it has some connection string, it has some credentials, etc. to connect to. It does that, but at the end, it sends me a user. Same thing with the Firebase method, specific method. So this is a partial view of the class. And if I look at the class in full, for example, the Firebase authentication repository, this is the overridden sign-in method, which all of them have to have. And this is some Firebase specific method. And all it does is it delays things by 10 seconds. Okay? All this is doing is it's a future delay 10 seconds and it's doing nothing. So basically at this step, we will wait for 10 seconds and then we will get a mock user in this implementation. So, up to now, we have created an abstract class authentication repository. We have done 2 implementations of the authentication repository, which are distinctly different to each other, but they all share the same method sign in. Okay? Now, the way I inject the repository into the app is here. So this was my material app. And before all this repository stuff, when I was building the app, I was just returning a material app. Now, I've wrapped my material app with a repository provider. And the repository provider returns a Firebase repository, Firebase authentication repository, as an authentication repository, because everything in my app depends on this abstract class authentication repository. But I'm going to either send a Firebase or Okta, right? I cannot send the abstract one because it doesn't have an actual. The method is actually doesn't do anything. But when I say this return, this parenthesis, send this as an authentication repository, because the app expects an authentication repository, this works. But what I'm sending is actually the Firebase authentication repository with its distinct method, okay, to the app. Any questions here? Okay. So the next thing, I hope this is not too small. The next thing is about a login page. Okay, so now I'm building a login page, and it's a stateful widget. And here I'm not showing the top of the login page, but I'm just showing the state builder, right? So the stateful widget has this initial part, but the one that actually paints things on the screen is the create state method, which creates this. So it has a few things. First of all, it has an authentication repository, which is again the abstract class, called repo, and it has this name late in front of it. Okay? What late means is that you're telling the compiler this is not going to be null. It is going to be filled in for sure before being used. That's what late means. So it's a final thing. It's not going to change. The only thing is I don't have it yet. Okay? I'm only going to get it in a few minutes, but I'm definitely going to get it before I call it. So it won't give an error. So that's late. Now the user, obviously the user is null at the moment. So therefore I have a user question mark that indicates that it's a nullable parameter, nullable variable. And it's currently null. Email and password, same way, we will fill those in, and they are currently null. A variable called busy, okay, it's false, so page is not busy. there is no spinning indicator. At the beginning, the page is not busy. The form key, I'm going to come to it later, ignore it for now. One of you see there is an override init state and override build, okay? The two of them, the init state and build come with an override before them. What does that mean? That means that the stateful widget expects you to prescribe what is my init state, what is my build method, okay? So we're now here saying, okay, your build method is this. This is what you're going to paint. And init state, we haven't covered it yet, but this is the time to cover it. Init state is a routine that the stateful widget runs when it first fires up. And that's it. So it's an initialization routine that it does, and it runs it, and that's it. So, and here, the body of the object. So we have, again, a scaffold, which is the familiar thing, an app bar, okay? And then I have a single child scroll view. Then I have a column inside, which I've padded 20 all around, okay? The column is shrunk to minimum size. It's pushed to the left-hand side, cross-axis alignment start, and it has a few children. The first child is a text authentication status with a label medium font size. And the way I get these is, again, theme of context.text theme.label medium. The next text is, I'm checking if the user is null. I'm going to print unauthenticated. Otherwise, I'm going to print user.firstname, user.lastname. Now, why do I have an exclamation mark there? Yes? Yeah?
Because you're purposely telling the compiler that you know it's not null. You don't care about the error.
Exactly. So because I've already checked here that it's not null, right? There is no way user can be null. So therefore, user.firstname is definitely going to be there. So I'm saying, user.firstname, don't give me an error. I put an exclamation mark. I got it. Okay? So pay attention to this. This is something that you need to learn. And then we have the form, which does the login. We will get to that. But this is my login page. And we'll also see where we will use the busy, etc. in a second. Any questions on this? Yes?
How do you assign the repo field? Because is it in the constructor, or because I did see that in the previous slide you had the repository provider.
The repository provider is at the top of the app.
Yeah.
Okay. Now the repository itself, I'm only needing here.
Right.
Right. So how am I going to get it?
Yeah.
In a second.
Okay.
So this is how I get it. So if I open up these two, the overridden init state method and the login user method. So the init state method, this is where I'm filling the repo. And the syntax of filling it is basically you're saying you're looking at the context and you're looking for a repository provider of type authentication repository. So basically this angled brackets here mean that I'm looking for a repository provider of the type authentication repository in the context above, right? That's what it basically translates to. And I'm setting it equal to the repo, which I said it was going to be late initialized. And in fact, in the init state, it gets initialized, okay? Now, then the init state is finished, okay? So the init state's purpose is to get, or get a handle on the repo, on the repository, so that we can use it later. Then I have another method inside this widget, a separate method called login user. And it does a few things. So somehow, when I have collected the email and password, I'm going to fire up this login user and try to log in, right? And the first thing it will do, it will set busy to true. It will say, I'm busy now, okay? But when it says, I'm busy now, to see any change on the screen, what do I need to do? Well, yes, I mean, repaint the state or change the state or trigger a new state build. So therefore, what I'm doing is I'm wrapping this instruction inside a set state command. And what this does, this pattern, what this does is that it sets busy equals true, and then it repaints the object with now busy equals true. And if busy is used somewhere to change something, it's now being taken care of. So this is the first thing that you do. You click the login button. What you want to happen is that you want the screen not to be interactable while the login is going on. Okay? So therefore, you set this thing to busy equals true, and then you use that busy in places in your code to lock them down. And we'll see that. The next thing is we await repo.signin method with the email and password. Again, I'm assuring that the email and password are actually filled in. Okay? And we'll come to that, why I'm sure about this. And after waiting, whatever, I mean, if it's a Firebase, remember, we put the Firebase method of 10-second delay. After 10 seconds, we will get a user. And once we get a user, we will again now set a state, right? And say busy is false so that it's interactable again. But the whole screen gets painted. And in that repainting, any changes to the user object, because we're displaying the user's name, last name, etc. Any changes to the user object are also painted because I am setting the state. Okay? Any questions so far? Yes?
In regards to the contexting, so is the context like the like parent widget of this widget, or?
No, context is basically the whole widget tree. So you're looking at all the way to the top of the app. Okay? It's multiple widgets in the widget tree, and the context is basically that entire line, and you search in the entire line until you get the first repository provider of the type authentication repository. Okay? Right. So for the button, the login button, I'm using this material button called filled button. And in the filled button, I'm using only two elements. The child is just the text on the button. There is also, some icon versions of this, etc. But that's the login. But more interestingly, there is an onPressed function for that button. I mean, if it's a button, it has to have a function associated with it. So here is that selector. If the busy variable is true, then the function is null. The function you call with the filled button is null if busy is true. So if the UI is busy or if the machine is busy, make sure that the filled button has no corresponding function, or it's null. And the beauty of it is that if it's null, it automatically sets its visual to a disabled state, right? But if it's not null, then this is what I want this button to do. Okay, and let's try to understand this for a second. So one of the one of the homeworks for the groups is to explain us forms, okay? So I'm giving a very basic thing about forms today, but we'll have to get a little bit more time on forms and understanding how forms work. So it's one of the homeworks for one of the groups. So now let's understand this. So if form key.currentState.validate, what does that mean? So the form key is the key to the form that we have on the platform. So every form item, like input item inside a form, once you put it inside a form, becomes a form element, okay? And for each element, you can specify a validation rule, right? And when you look at the top-level forms key, and then you look at its current state, because the form changes state, it looks at its current state, and when you hit the validate method, what it does is it goes to every element and asks for validation. Are you valid? Are you valid? Are you valid? If one of them says I'm not valid, then this returns false. And for some reason, if the current state of the form, and this is the way to do it, if for some reason, if it's not built yet, and you're trying to call this, and if the current state is not available, if it's null, then you want to return false here. It's just some safety. Because you cannot assure, you have to do other things before calling this otherwise, to assure that current state is not null. Anyway, so this is an easy way to do this. You go form key.currentState.validate. It validates all the objects. If they are valid, then you can continue to this thing. And when you continue to this step, you again go to the form key, current state, and you issue a save command. And what the save command does is that it looks at every element, and every element has a different save method, right? For example, the email field is going to save its contents to the email variable, whereas the password field is going to save its contents to the password variable, right? So with this, everything inside the form is going to be, therefore, triggered its own saved command. The form key itself doesn't create like a big map of saved objects. You have to specify that in the own saved thing. And then what it triggers is that because it's valid, because email and password are not null, right? They are not null because the validation has passed. And therefore, he can now call the login user function, which reads the email and password from this save command, which I'll come in a second. Any questions? So let's look at the structure of a text form field, right? This is your email form field. What parts does it have? It has a decoration called input decoration. And input decoration at this stage only we're setting the label text email. It has a validator. What does validator do? It takes the contents of this text field, which is the value, right? It's a function you define to check the contents of the text field to see if they conform to your validity rule. So if the value is null, or if the value is empty, then you return some text. And the text you return is effectively the error message that you display under the element. And because you're returning not null, it doesn't pass the validation test. It only passes the validation test if it returns null. The other implemented method of the text form field is onSave. And simply, when the save command is issued, the value is being entered into the email variable. And there is one more thing. I don't want you to be able to type into the email or password field while I'm busy. So what do? I have the read-only parameter, and I set the read-only parameter to true if I'm busy, and to false if I'm not busy. Okay? So I've now used for email, password, and the filled button. In 3 places, I've used this busy parameter, and I've locked down the necessary part. I could also use it to show other things. So now we're looking at the form, and what do I have in the form? The form has a child, which in this case is a column, and in this column there is 2 form fields and a filled button. Right? This is the filled button which we saw earlier, and these are the text form fields we saw earlier, and all of that is wrapped inside the form, and the form has a form key, which is a global key of form state. This is something that you just need to follow in this method, in this manner. So that's the form. It has the form key, and then with this way we attach to the current state and validate and save and log in the user. Okay. I think this is the explanation part. Now we can go to the code and pull the code and start working on the code. Any questions on this so far? Okay. Can you update your repository with git pull and then list the tags, and it should be lecture 7 start. And please pull your code and then take a break. And we'll continue after the break. Instructions and okay.
CSEN local.
If you can download it, save it as a new branch, lecture 7 start or whatever branch, and try to run it in your simulator while we wait.
ब्रांच को एक बार रिपोजिटरी हटा दो पूरी वापस ब्रांच हटा दो
You can check if you say git tag list, git tag.
बट बिना पुल करे
Oh, now you're ready.
वैसे आप
Yeah, you probably see new tags. You didn't have them before. Now you can do it.
लेटेक्स कोड आएगी नहीं
Because remember, Git is distributed, so everybody has a copy of the same thing. So you always want to pull anything for. And I think minus the name of the new branch. Yeah, you have changes that you have to either remove or commit. Sure. Now you can do it. Now you can do up arrow. Do we have the same computer?
It's what is it?
Oh yeah, the air and yeah. Kind of like this song. Oh, you got to work with iOS. I don't think I ever did that. I just have it on Mac OS.
You can install those servers.
Yeah, you have to follow the block.
设计难度太高。那你从来都不管电脑。
除非不行了再。
Oh, the first time. We're just gonna kill it.
All right, shall we start? We're missing too many. Right. Okay. Did you guys get the code running? Okay. Anybody not get it code running? Okay. All right. So let's first try to run it. So let me refresh everything. Let's try to run it with an empty email and password. Hit the login button. Okay? When you hit the login button, because the email and password are empty, they return this error message. Please enter some text. Okay? So that works. Now, so this part about the text form field has worked. And I think if I give a completely empty, so an empty string, or not an empty string, but basically a spaces still works. So what would be one way to check for the spaces, you know, a string full of spaces? What string command gets rid of the spaces?
String that is null or is white space.
Trim. String.trim gets rid of the empty spaces. So let's put in the validator, okay. Also, you can use value.trim to avoid full of spaces. So usually when you get an email field, right, when you have some text in it, you first want to make sure that it's not null. If it's not null, then you want to trim it so that any spaces before and after are gotten rid of, and you only get the bulk of the text, okay? So I'm putting it here as a comment. We're not going to deal with it now, but it's something that you should keep in mind. Okay, so now let's fill it with some data. And what we expect to do is we're going to, so this app is wrapped with this Firebase authentication repository. And what you can do always to look inside these things in VS Code is right click on it and go to definition. Okay? And then when you open a folder, a file, it comes in this italics. If you double click on it, it lodges it into the, or it pins it to the web. So, okay, so Firebase Authentication Repository, the sign-in, it first calls this some Firebase method, which has a 10-second delay, and then it returns a mock user. And while we're at it, the Okta Authentication Repository has only a 2-second delay. Okay, that's the only difference between them, and they both return some mock user. Okay, so obviously the actual implementation, we're going to look at Firebase auth, etc. later, but this is to understand the repository. So then I hit the login button. If I hit the login button, let's go back to the login page. If I hit the login button, I'm eventually going to get this login user somewhere here. Variables. So it will hit this login user function, set the state to busy, and after 10 seconds, it should bring me a user. So this unauthenticated should change. So let's kick it. So it's gone to busy, and these are no longer editable. It's selectable, and it's checking this 10 seconds, and then it came back with this user, and obviously the user's name is from lorem ipsum, whatever, and it's again clickable, the busy state. Now, let's go to, any questions so far? Anything you want to see in this code to get it explained in this code? So the login page has this, is a stateful widget, and we concentrated on this login page state, right? We looked at this init state, override, and we created this login user, which does the login, okay? And in the authentication repository, I think we have everything here. So the only thing is, let me change this to Okta now. Okay, so I do a refresh of the code. Okay, so now my repository is Okta. What it should do is that it should now come back in 2 seconds. And I fill in, again, some kind of email and password, hit the login button. Within 2 seconds, it comes back. So now we have changed the repository. And without having to change, we're only changing at one place in our code, we're able to go to a completely different repository. Obviously, each of these repositories will be thousands of code in reality, but nonetheless, it's being developed separately, and it's also being tested separately, so you don't have to mess anything with your code. Okay, so that's what I want to say about the repository pattern. And any questions so far? Yes, Rashid.
In the on-pressed part, there's after busy there's a question mark null. What does it do? What does that mean?
Here.
Yeah, the question mark null part. Yeah.
This one.
Yeah.
So this is basically a conditional, inline conditional, right? So it looks at busy, which is a Boolean, and then if it's true, it returns null. If it's false, it returns the function. So it returns null. So onPressed becomes null if busy is true, and onPressed becomes this function, void function, if it's not true, if it's false. So these conditionals, again, we use it here as well. We use it here. User If the user is null, the content of the text should be unauthenticated. If it's not null, print it out. Okay? And this is called interpolation, yeah? This is called text interpolation. Okay. So, what's ugly about this? What is not nice about this? Explain it a little bit more. Oh, you mean this? The UI. Okay, fine. No, I wasn't asking about that. I was asking about the code. What's ugly about this code? Or what's bad about this code? Yes?
No separations of concern, maybe?
Right, so there is no separation of, the view versus versus calling the repository. We're calling the repository from within the view, right? It's not really the greatest thing. And then we have this busy variable, which I use in various places to turn the UI unclickable. And then, again, it's not the cleanest way to do things, right? It's good to demonstrate something. It's good to demonstrate the functioning of the reason I did it purposefully, obviously, to demonstrate the functioning of the stateful widget and, what happens when you call the set state, etc., how it all trickles down. But clearly, this is not the way to do things, okay? And now let's have a look at how we can do things with the block pattern. And then if we have time, we'll get into implementing it. Right. So block pattern has two ways it can work. One of them is called a qubit, okay? And what a qubit does is think of a restaurant and a kitchen. So qubit is sort of like the kitchen behind the local restaurant, right? And when the restaurant opens, the kitchen opens as well, right? And any orders into the kitchen go from the restaurant, and then food comes out into the restaurant. It's basically very closely knit to the page. So let's say, for example, the login page, all of these things of getting the login, filling the user, checking the busy state, etc., all of that stuff should be really done separately somewhere, okay? And the login page should either have a single view, or maybe it should have a few views depending on the state. Like, for example, before I have filled in the email and password of the user, it should have one state. While it's operating, it should have another state, another view. And once the result has arrived, it should have another view, right? And if there is an error, it should be also an error view. So typically, you should always provide for an error page in your design. So that's then could be done in the following way. You have your login page. When you bring in the login page, it creates this login qubit, right? It creates that little factory on the side to do things. And what the qubit has, it has certain properties, just like the busy user email password type of things that we were keeping in that state. Those properties should really be living inside the qubit, okay? And the qubit will have certain methods. Certainly one of the methods of the qubit will be to call the repository sign-in method. And one of the properties of the qubit will be the repository, because the qubit should be able to call the repository. So the repository it should be one of the properties, and the methods should include a sign-in method, okay? Then, depending on, so when the qubit initially comes in, it emits a login state, and it goes to a widget called BloC Builder, okay? And BloC Builder sits pretty much, it could sit above your scaffold or below your scaffold. So if we look at this is my scaffold, right? It has this thing up on there. It could have bottom navigation buttons, etc. It could have a lot of things. And what I could be changing would be just the body in the same scaffold, or I could be changing scaffold every time. It has different uses and different advantages in different cases, so there is no single formula to say that you change the view inside the scaffold or you change the entire view including the scaffold. But in any case, you want to be able to switch views based on the state. Okay? So if there is if the state is an error state, you bring in the error view. If the state is if the user is empty, the form state, let's call it, email password form state, it shows the form. As it's fetching data, it gets the data. Maybe there is a forgot password view, maybe display the user view, etc. Or, everything is possible, all these views. Now this is basically a very clean architecture, right? So why it's a clean architecture? Because you can separately design all of these pages without having to put too much logic inside the page. The only thing that this is going to do is a text field and a button that connects to one of the methods inside the qubit and say, okay, log me in with this data, right? That's the only thing that this thing is going to do. This thing is going to display an error. This thing is just going to, let's say, show a spinner in the middle of the page, right? And you can do this. Any questions on this? Yes.
Yeah. So the properties and the methods are interlinked, right? So based on the properties, like for the qubit, the methods would be called something like that.
No. The properties of the qubit are internal working properties, like the email and password that the guy has entered in this form. We update the email and password in the qubit. Okay? The methods of the qubit can be called from the UI. It can be called from any of these pages, or it can be called internally as well. Okay? The qubit can also subscribe to some data source, and if the data source, it's subscribing with a WebSocket, if the data source changes something, it can emit a new state as well, in some cases. You had a question.
Yes, so for all intents and purposes, the login qubit somewhat similar to a factory class almost, or does it have some differences?
No, it's not. It's not similar to a factory class at all. It's we'll do it, and then you'll understand. The login qubit is basically just the whole system is the ability to emit states, and then wherever in the GUI, that type of state is captured and used to build something. Okay, this BloC Builder it builds on the current state of a particular type. So a login state is the abstract class of the login qubit. But the individual states of the login state is login error state. That's now not an abstract class anymore. It's an actual class that extends the abstract class. Login email password form state, login waiting state, login forgot password state, etc. All of these things, based on that, you capture this and you build the GUI. And the beauty of this one is you no longer have to work with stateful widgets. So the setState method of the stateful widget was repainting the widget based on certain variable changes and based on certain conditions, right? But you are now explicitly setting these conditions with the login state, and you have a catcher here called BloC Builder, and the BloC Builder then catches a new state, and it automatically triggers the build. So inside the BloC Builder, these things that you show, they no longer need to be stateful widgets. They can be just stateless widgets, much simpler to deal with. Okay? And okay, I know this is a bit too much to take in, but I want to just finish this this part of the lecture. Now, the next, yes, Piyush.
Common pattern used by companies, is this the common pattern used by companies like in making application? This pattern.
Well, this pattern is really very Flutter oriented because of the widget structure. Although, yeah, it's very Flutter oriented, and it's it basically solves 99% of your problems. So another thing is BloC. Okay, BloC is similar to. So remember here, these things, they go and call these methods. Yeah. So think, for example, there is a method here, whatever the method is. It can be called by the email password form or by this form. They both can call a method. Now, you have no way of knowing which one called this method inside your block, and when you're doing tracing, etc. Whereas, think of a way where instead of calling a method, these things emitted events into the field, and there was somebody catching those events, right? It's the same thing as calling a method, almost, right? But it's an event you emit, and the block catches that event. And obviously, inside an event, you can put data as well, right? The event is not just on and off. It's basically, you can put data into you can put into the event the email and password values and send it off, and whoever is going to catch it, catches it. So the BloC pattern does that. And one way we do the BloC pattern is we create a widget called multi-block provider, okay? And we define all our blocks here. And what could be these blocks? Like this block could be the theme block, okay? It manages everything for me with regard to the theme. I have the dark theme, light theme, contrast theme, and so on and so forth. This block manages that. How do we do that? We're going to see. This block could be managing everything to do with login and authentication. This could be, for example, of a Spotify app. It could be getting all the recommended tracks of the month. You could have multiple functions for these things. And then you wrap all this into a multi-block provider, and you wrap your app with it. Then all of these blocks are available with the BloC provider method. Just like we had repository provider, we are now able to get them with the BloC provider of a certain block type. So if I'm looking for this block, I write BloC provider of this block type of context. And then if I want to, somewhere in my code, I want to refer to the state of that block, and I want to build something based on that state, or rebuild when the state changes. I can just stick this anywhere in my code, any place in my code, and I say, this is a block builder. Look for block A and its state. Every time its state changes, repaint me. Right? This is that block builder widget, which is again very handy. Just like, for example, we said an observer, right? You're trying to change the FX pairs. Now, think of, instead of observer, you have an FX block, okay? And in the FX block, or for example, euro-dollar block, the currency has changed and it emits a new state. Currency has changed state. Then if you're displaying your currency in a little bit, in a little text, and you wrap that text with this block builder, it will constantly repaint that text without touching anything else in that GUI. So what are the components of a block? So this is the main part of a block. So you have 3 files that come with a block. The main file of the block, then you have the states. So you have an abstract block state. And then these ones extend that state. And then you have events. You have an abstract block event. And then these events extend that event. How are we doing on time? Okay. Cool. Okay, we're gonna do some coding now. So first of all, because we have this block extension loaded, okay, we can easily create a block or qubit. So let's start with a qubit. In the pages, the way I want to do this is I want to create a new folder called login. Okay, and inside this login folder, I want to create a login page. That will be, what will be this page? It will be this page. It will be this page. This is the login page. And inside the login page, we're going to put all this logic about the block builder, which will switch basically based on the state. And then we will create these views. Okay? So inside the login directory, I can again double click and choose a new qubit. Do you see this on the bottom? Choose a new qubit. And we call it a login qubit. So under the login, it created this qubit called login qubit and login state. So let's look at these, what they are. So the login state, so what the field means is an abstract class that can only be extended within this file. It cannot be extended outside this file. That's what sealed means. Okay, but otherwise it's just abstract. So we have an abstract login state, and it already gives me an initial actual state, login initial. Okay, so when the qubit is created, it will emit login initial state. So you can catch that state and do whatever you want with it, but it already gives you a initial state. We're going to fill in the states here later. So that's the login state. Now let's look at the structure of the login qubit. So this part function together with part of, so login state, as you can see here, login state has this thing on top, part of, and it doesn't have any imports. So the thing about this part of language is that it's part of the login qubit.dart. So any imports from login qubit.dart are also applicable here. So I'm not importing anything else. And login qubit says part of my thing is in login state. Okay. All right, so that's the part of language. And login qubit extends qubit of a type login state, right? So this thing operates on this abstract class login state. The first thing it does is, this syntax, super login initial, it basically emits the login initial state when it's created. Okay? So the login qubit emits the login initial state. Now, how do I create this login? So my login page, what should my login page be? Let me get a stateless widget, call it login page, and import the material library to it, right? So this login page is a stateless widget returning a container. Actually, I don't want, I want to not, I can leave the container for now in there. But what I want to do is I want to create my qubit, because remember, when I'm calling the login page, my qubit is not yet created, right? We've defined the qubit, but it's not yet created. It needs to be created when I'm calling the page. The way we do it is that you go and command dot on it. You're able to do this? Yes.
How did you get like the pre-filled class in
Here. This one. You mean the stateless widget or
Yeah.
the qubit?
I know the stateless widget. Because
So
I
the
did that.
stateless widget is simply, you say stateless. You know we have this extension called awesome Flutter snippets.
Oh, okay.
So if you have that, you can fill in that by just a few keystrokes. Okay, so stateless, let's just undo. So that's my login page. And what I want to do is I want to first create my qubit. And the way I do it is, again, command dot. And now I'm going to wrap it with a block provider. Going to wrap it with a block provider. And it doesn't know what a block provider is. And I'm going to say, okay, go and import the Flutter BloC library. So subject block, we need to see what subject block it is. I mean, it can be block or qubit. In this case, we want to create a login qubit. And it's defined in this place, qubit, login qubit. Okay? Not okay.
Yes, okay.
So I've taken my container, which is what the build, so let's go back. So the build of the page provides a container, and then I want to wrap this container with a block provider. So I do command dot, click on block provider, it brings this. Obviously, it doesn't know what block provider means because we don't have Flutter BloC imported. Again, you do command dot, it suggests to import that package. And the subject block we need to fill in as ourselves. Obviously, this is now the login qubit, and the definition of it is here. So what we've done is that in this page, new login page, which was just giving me, which is a stateless widget of container, it's now a block provider of this. container. Okay, and it creates the login qubit, and it goes on to show the container. Now, the container, so now if the state changes, there is nothing to catch us. What do I need to repaint the screen when the state changes? What do I need? What widget do I need to be able to repaint the screen when the state of the qubit changes? BloC builder, you remember from BloC builder. So we need to have a BloC builder. So I wrap the container with a BloC builder. You see here, the pattern is here. And it says subject block, subject state. So in this case, it will be login.
Login qubit.
Yeah. Login qubit, login state, right? So it asks for the qubit, which creates these states, and the state object that comes with it. So it asks for these pairs. So it's a BloC builder that depends on this. And what's implied is that it's going to look up the nearest login qubit and attach it himself to that, right? That's what it means. I mean, instead of this long thing about saying, you know, BloC provider at blah, blah, it, with this notation, it basically does that. So now, what we can say is that now we can put a switch statement here, okay? And let's, before we do the switch statement, let's do something else. So this is now, at every time the state changes, whatever the state is, it will always show a container, basically an empty screen right now, whatever the state change is. And the we can test basically what that state is. So this login page, you know, previously our main was looking for the other login page that we created, okay? And let's call this, let's call the other login page, where was it? So this, is it this one? No, this one. So this login page, let's call this, okay, stateful login page, okay? And let's change the name of this as well to stateful login page, okay? And the main dot now, this login page, but this login page doesn't exist anymore, right? So the main dot, what we're going to show, this login page, he's looking for it inside the stateful login page, but we've changed the name of the object to stateful login page. So now I get rid of this reference. Actually, the user list page is also not used in this case. And this one is now sitting in pages/login/login page, which is the new one that we created. Okay? Make sense? So we created the login page here, this one, and this login page is just going to show a container, so it's going to be an empty page. Okay, let's see what happens. Okay, so it's showing a container and it's completely black because there is no surface coming with it. Okay, and it's what's called this material surface. There is no material in there from that point of view. It's a container, so that's why it's black, because the container is already transparent. Let's leave it there and let's go back to our pages. So under pages, I have the login directory. It has a qubit. It has login page. And what is also nice is that let's go and create a folder called views. So I have a login page. This is its kitchen. and this is its view. So we will fill in the views in here. Okay, so in the views, let's create a first view. Let's call it error view.dart. Okay, and the error view should be a stateless widget called error view, and it should just return a scaffold app bar and body center text mistake somewhere, yeah. Okay, so the error view is going to return this. Okay, error view is going to return this. Now let's try to trigger this. Okay, so in the login qubit, I'm going to define a method called error. And what it should do is it should emit a login error state, which we haven't defined yet. So let's go to the states and we create a login error state. Okay? Create a login error state. When I go back to my qubit, it's actually going to be able to emit this one because it knows what the state is. And the next thing with this qubit is we want to trigger this error. How I can trigger this error, for example, one of the common ways of using these qubits is define an init function. Right? Whenever you create the qubit, you also immediately call the init on it, generally. It initializes something, typically. And this init function can be an async function. And what I want to do is that after, let's also create a new view here called initial view. And so, and this should just say login. Okay, so I have an initial view and an error view, and the initial view should be displayed with this state. The error view should be displayed with this state, login error state. Okay? Now, in the qubit, I have an init, because immediately when the qubit is created, the login initial state is being emitted. Okay? Login initial state is being emitted immediately when the qubit is created. With the init, I can say await So with init, I'm going to wait for 5 seconds, and then I'm going to call the error function. And error function is going to emit the error state. Okay? Now, it's going to come together. I want to just change this from error state to login error for easier. It's to make sure that because login initial, login error, login etc. Okay, so the login error, login initial. So this should effectively after 5 seconds do that. But where am I calling the init function? So when I'm creating, so I go to login page where I'm creating the qubit, right? When I get into the login page, the first thing I do is I create through the block provider syntax, I create the login qubit, and immediately after I create it, I call the init function. So I'm chaining. So what this is basically saying is that create the login qubit and immediately call the init function init inside it. Okay, that's a syntax. So what this will do is that when the login qubit is created, it will emit login initial. So the builder is going to try to build with the state being login initial. After 5 seconds, it will have a state called login error. Okay, so let's test that. So it's always printing container, but we can print state.runtime type. So which state it is, I can simply see from here state.runtime type. So let's actually I think is it doing it? Not doing it. Okay, so you see what happened is initially it said login initial, and after a few seconds it gave me login error. Okay, now let's see how we can paint this on the screen. What is the mechanism to show this on the screen rather than painting, rather than this? So let's get rid of all this stuff. So the builder, for the builder, what I can do is that I can do switch state.runtime type. Okay. So case if it's a login error, return error view. It doesn't know about the error view, so we import it. Case login initial or default, return initial view. So it's in the, I mean, it did this part without running the whole code. That's why we're in the error page. We will now run the code again from start. So let's just look at this again. The state comes into the builder. Every time the state changes, it hits the builder. Okay? And then we have a switch statement where we look at the runtime type of the state. So if it's login error, we want to show the error view. If it's a login initial, I want to show the initial view. And the list can go on, so and so forth. So each of my views are now nicely separate from each other. They do different things. and I can work on the views separately, and that would be the way to do it. So let's restart by this. So it first says hello, right? And a few seconds it should go to error, because after 5 seconds it triggers the error with this mechanism. Does this make sense to you guys? This logic, this qubit thing. All right? It's a again, look at this directory structure. I think that's the important thing to note here. This directory structure. We've created a login page which has its qubit, which is the engine that does everything, and then you have the various views. Of course, you could have other things in there, but that's anything that to the. What we haven't done is we haven't injected the repository yet. What I'll do is after this class, I'm going to also do the. I'm going to implement the other login page here, so you can see. But the logic is very self-explanatory, and that's the sort of the switch mechanism that's the heart of this state concept, state versus view. Okay, and one more thing I want to demonstrate to you. So let's say in the login qubit, I create a variable so I've created this variable, class name CSEN 268, okay? Now, I want to display this in one of my views. How am I going to display this on one of my views? That's also one of the things. So let me go to initial view, where I've written hello. Instead of this hello, I want to display this string from the qubit. Let's call this text. Let's build. Let's get it here instead of writing it inside. So now this text, it's block provider of login qubit so we import this and we import Flutter BloC library dot class name. So inside my view, I can access the properties of the qubit with this way. So I'm basically looking for the first login qubit above me, and obviously the login qubit is above them because of this construct. The login qubit is built above the view. So therefore, if you're calling from inside the view, login qubit is sitting above you, so you can attach to it. So the initial view is effectively a child of the login qubit because it was created in this context at this stage. So inside the initial view, I can pull that parameter in this way, block provider of login qubit. I can pull that parameter. And when I pull that parameter, I can print it here. So let's see if it will work. So as you see, that text has been